Good evening, ladies and gentlemen. Um, I'm Kaushal Patirana from the Building Service Engineering Sectional Committee. I warmly welcome you all to the 10th webinar organized by the Building Service Engineering Sectional Committee for the session 2021-22. Today webinar will be very interesting and well-timed one. Our topic is improving operational performance of the buildings. Well, we all now experiencing the financial limitations and cost escalations, don't we? But we don't want to limit our luxury environments or the comfortable living conditions. Did we ever think who has paid for us? How this environment survived? Though the cost of operation is escalating in an alarming speed, revenues are decreasing at the same time. Management of physical assets and sustain any kind of business is a great challenge. How far we can slim down the operational cost without affecting the services? What would be the limitation for optimization? All engineers have to play a vital role to overcome these challenges with proactive approaches. Let's find out in a while. Today's objective of the webinar is to optimize the building performance further without reducing the quality of building services, especially in modern building context. Thank you all for joining with us, and let me introduce our speaker today. Well, Engineer Indradeva Mendis was graduated from University of Moratuwa and a chartered electrical engineer with more than 25 years of experience in building service engineering and facility management. Engineer Indradeva is well experienced and carries a great exposure in many engineering fields. He has won the Energy Manager of the Year award in 2013. Further, Engineer Indradeva has also obtained an MBA in Management of Technology. He also shares his knowledge as a visiting lecturer for many institutes such as ISL, University of Moratuwa and University of Peradeniya. Further, he serves as a resource person for several professional forums as well. Having ties and closely collaborated with many professionals in the field, Engineer Indradeva has wide vision to grow the building services industry to an efficient and economical Sri Lanka. Well, ladies and gentlemen, without any further excitement, please join with me to welcome our speaker tonight, Engineer Indradeva Mendis. And one more thing, I would like to remind you that there will be a Q&A sessions at the end of the presentation. So you can post your questions to the moderator by selecting the moderator icon in the chat box during the presentation. We will direct all your questions to the speaker at the end of the presentation. Okay, guys, let's move on to the presentation. Over to you, Engineer Indradeva.
Good evening to all of you. Kaushal, thank you for the introduction. Now, in my area, we are experiencing the scheduled power cut. So it's getting dark, so that I don't think switching on my video is going to make anything make sense. So I'll keep the video off, and throughout the presentation, I think we won't have power, but I can see the laptop because there's a small LED lamp on my computer, and so I'll keep the video off. So and proceed with the presentation. And before I move on to the presentation, while I was listening to Kaushal, something came to my mind, and he mentioned that I was graduated from Kadupath. Actually, I did electronics and telecommunication. I was very interested in doing it, but I didn't know why I wanted to do electronics and telecommunication. And once I passed out, I joined the construction of a modern building. Then I end up doing building services engineering. Even I didn't know that name. Later, I left the industry as a facilities manager. So then recently when I was talking to my daughter, she's also electronics engineer from the same university, from the same department. She talked to me about some electronic stuff. I didn't know she was talking about electronic. So I asked her, what are you talking? And she said, Tata is about electronics. I said, is it? Then only I realized I am no more electronics engineer. Right? And I have been working as electrical engineer, but I don't have a degree in electrical engineering. So I'm not electrical engineer either. And then worked as a facilities manager. I don't have any formal qualification in facilities management. So not a facilities management, facilities manager as well. And after leaving the industry for a while, I had about a couple of years, which I used to read about building services, technology, and all that. And after reading many articles, books, internet, all that, some strange thing came to my mind. More I read about the building services and all that, I realized that I don't know. More I read, I realize I don't know. More and more, I don't know. So then when you are asked to conduct a program like this, you feel a bit uncomfortable when you know that you don't know. So more you read, you realize more and more that you don't know. So this is the reality. And today I'll be discussing or presenting something that I have acquired over a period of many years. These things may be right or may be wrong. To my knowledge, I have practiced and it worked. So it's better for you to try and see whether it works or not. I know our audience may have designers, contractors probably doing installation work, and I don't have experience in any of these areas. I have little bit of experience in building operation. And before we move on to the subject area, I thought of sharing something as a lecturer in some of the universities, as a visiting lecturer, where I have observed something. So I think I need to share this with a forum like this. And day by day, we are trying to collect qualifications, paper qualifications, maybe BSCs, MSCs, CPDs, all kind of paper qualifications. But our focus on enhancing knowledge is not that great. So getting a qualification for me should not be an objective. Getting a qualification is only a key performance indicator. Just try to see whether you can figure out the difference between objective and a key performance indicator. Getting a degree or CPD or any kind of certificate or qualification should be a key performance indicator. So key performance indicator will never become objective. It's a fact. In any organization, they have key performance indicators, but they are not objectives. Your objective should be to enhance your knowledge. As a result of enhancing your knowledge, then you will get whatever certificate that you want. That is only a key performance indicator. That is number one I want to share. You can think about it. You don't need to agree or disagree, but you can think about it. This is from an old man. So the number two is that you have to make decisions. I made a very kind of a stupid decision when I was very young. I was about, I think, probably 27 years. Just joined a large facility, high-rise commercial building, as an executive in the engineering department. Due to certain circumstances, due to some social situation, I made a decision to evacuate the entire building as the electrical engineer or executive in the electrical engineering department. And I had nothing to do with the security department, but when I gave the instruction, they obliged. They evacuated the entire building. So next day there was inquiry, and who has given authority for this guy to evacuate the building? I almost lost my job. But fortunately, the general manager was a Singaporean. He realized he made the wrong choice. He made the wrong decision. At least this man is making decisions. So he realized this person has the managerial material because he's making decisions. Can be a stupid decision, but I think that is very important. When I was talking to this sort of people, my senior people, we realized that what they want us is to make decisions. Without making decisions, you cannot gain experience. The decisions can be right, decisions can be wrong, but decisions can't be like it can be like calculated risk, but it can't be a gamble. Because engineers are not making gambles. Right? Gambling is not part of our life. We make decisions based on facts. So based on facts, your processors will tell you what decision you have to make. That decision may be right, may be wrong, and may be right to certain people and may be wrong to certain other people. But you have to make decisions. So our engineers should make decisions and become managers. Then only you can manage things, not only just technical people. That is number two. Number one is that you need to gain knowledge, but be aware that whenever you start gaining knowledge, you will realize that how little you know. That's what I am feeling at the moment after working in the industry for 25 years, how little you know. Right? Number two is making decisions. So I mentioned a stupid decision I made when I was very young, still survived. After that, I made so many decisions. And very recently, I made a similar decision. I'll tell you that as it just came to my mind. We were doing a refurbishment project. We found a good concealed cistern. It is a cistern tank, but it's a very good quality, and it will last for 10 years without any problem. You know that concealed cistern will go behind your wall. You can't be repairing it every other day. It has to be there forever. But unfortunately, the commode bowl offered by them was not good enough, not big enough. When you pee, it will splash over. That's a problem. And we got another offer from another supplier. The commode bowl is okay, but ordinary concealed cistern, it is behind the wall. So we asked two suppliers, can we get the concealed cistern from one supplier and the commode bowl from the second supplier? And they agreed. They signed an agreement, and with the decision, I met our CEO. He's not an engineer, but he's from the finance background. He listened. I explained why I'm doing this. So I asked his permission. He said, okay, go ahead. Now, this system, whatever, this refurbishment over. And for last 3 years, not many issues. But I won't say that is the right decision or the wrong decision. There are no right decisions or wrong decisions. All situational, based on your gut feeling, based on the information you have, based on the experience you have to make decision. This is a very unusual decision, I suppose, because since you are all from building services sector, you will realize that very rarely that we mix a concealed system with somebody else's commode board. So there can be mismatches, incompatibilities, but we got them both parties to check it 100% and sign off. And this is another example for a decision. Okay, those are the only okay, with this, I will move on to the presentation. I think there'll be a Q&A session, so that if you have anything, you can ask me. Right, I will try to give whatever the possible answers, whatever I know. Right, and when I joined building services industry, not knowing that I'm joining the building services industry way back in mid-90s, and I didn't know the name of building services at that time. Right? And as an electronics and telecommunication engineer, this is how Colombo looked like in 1995. Bit of a gloomy skyscraper, right? Skyline was like this. Unfortunately, this skyline lasted almost, I think, almost 2 decades like this. We didn't get many high-rise buildings. We didn't get many large hotels, hospitals, not many large buildings. So building service engineers didn't have much work. But today, if you look at the skyline, it looked like this.
It's
It's
me,
different. Yeah.
Mr. Engineer.
Yes.
Yeah, I think the presentation is not visible.
Sorry, that's my mistake. Sorry, give me a second. Okay, where is it? I'll always make this mistake. Thank you for highlighting.
Yeah, now we can see. Yeah.
Now you can see, right? Sorry again. Thank you for reminding. Right. The photograph at the bottom, this was the Colombo skyline when I started my career as a building services engineer. And this lasted for about at least 15 to 20 years like this. And now it looks quite different. You all can see this, right? So that means a window of opportunity. Right? Jack Ma used to say that after taking all the opportunities by all the leading companies, there are plenty of opportunities. He says that many people see problems as problems, and he sees them as opportunities. So getting buildings, new designs, for some people may be a problem, but I think it's an opportunity. So for building services engineers, this is a good time, I suppose. They can show their colors. And when it comes to buildings, we have to see what do we expect from a building. I like to call them facilities because they facilitate certain things. And what do we expect from them? Oops. Sorry. Give me a second. Can you all see the presentation?
Yes, really, we can see.
Yes.
Okay, so now I have been talking to myself to see what is analogous to a building. Then I realized it's more like a human being. This is my own thought. I have not taken it from anywhere. This is what I feel. And just like about the people, we always go for beauty. I think it's common with many people. So even when it comes to building, people still think that the beautification or the beauty is the number one. But most of you, all of you are matured enough, you will realize that your attraction to beauty will not last forever. Right? Even if you ask from Abhishek Bachchan, who is the proud husband of Aishwarya Rai, he will say it's maybe like a table or chair at home, even though she is a beauty queen. That's a reality. So building, no difference. You might look at it as a new design, new shape, but over a period of time, maybe within 1 week or 2 weeks, it may not make you excited anymore. That is human nature. Then you will focus on what can I get from this building? Is it supporting what I'm doing here? That is functionality. Is it safe? Is it reliable? Now, building services engineers walking into it. Even if you take the facade, nowadays facade is like your skin. It's no more just a beauty. Beauty is important. I won't say the building should look shoddy. It should look beautiful, but that should not be the number one. But as human beings, we also focus on external appearance. We are very concerned about external appearance and not very concerned about what is happening inside. right? And when I was watching the video, there were many parties, many functions. I was wondering, where were the bottles? They were not shown. But there are many occasions, many incidents. Bottles are not shown. They were hidden somewhere. So I was wondering, how can these people are so excited without these support services from the bottles, right? So we are also not very concerned about what is happening inside. Just like a building. Just ask yourself, can you make a building to perform without having the inside stuff or your building services functioning properly? Not at all. You can't. So when we grow old, only we realize that heart is not beating the way it should be, kidney is floating, no, the liver is floating, kidney is making noises. At that time, it may be too late for a person, but for a building, it's a matter of changing it. But as far as the performance of a building is concerned, what is inside a building is much more important than how it looks. But it doesn't mean that you should not wash your building. You should. And make sure that your facade perform as it designed. Then, as the building services engineer, there's a role that you have to do. Look at this person in the skeleton in the video. Oh, sorry, in the screen. Most of the people are quite built strong. They are quite strong, built strong. But what it makes a person intelligent, which gives the value to the person. One is the function of the brain, other one is the mind. So brain of your building is the integrated services and supported by a BMS. Then what is the mind? This strong looking person, looks like a male, I think, without a properly functioning brain and a good standard mind has no use. Maybe just like another animal. So this person make valuable because of the properly functioning brain and the mind. So brain in the building is integrated services. The mind is the building services engineer. So we need to be mindful about this. We should be able to demonstrate to the building owners, building operators, that running chiller is not by just the Mahjong fellows or technical fellows. It's by the mind and the brain of the building. So it's not anybody's fault. It's our fault as the building services engineers if we cannot demonstrate. So then let's find out how we can demonstrate this. So let's see what we expect from a building. This is what I feel. 4 things I have mentioned here. One is comfort, functionality, safety, performance. I have grouped them under effectiveness and efficiency. So this is not a hard and fast rule. This is what I feel. You appreciate a performance or the performance, the building that you work, live, or occupy based on these things. It has to be a comfortable environment. It should be functional and you feel secured and safe, and it comes to you at a reasonable price. Then only you say, okay, the service that you are getting is value for money. People don't mind paying a little bit more, provided they get equivalent value. The first 3 elements, comfort, functionality, and safety, I group them under effectiveness. And the performance, efficiency. So what is efficiency and effectiveness? In simple terms, for me, effectiveness is the doing the right thing. Efficiency is doing things right. Very simple definition. Right? And then when it comes to, I think probably all of you have heard these two terms, doing the right thing and doing things right. We need to couple them. And same thing has been explained in total quality management, TQM. What they say is satisfy your customer all the time. That is effectiveness. Satisfy your customer all the time with minimum cost, not at any cost, with minimum cost. That is your efficiency. And there's one more thing that they have included, with the support of everybody. Otherwise, you cannot sustain it. Otherwise, it won't be consistent. That is called value for money or quality in simple terms. So when it comes to efficiency, engineers are quite keen about efficiency. And we call it engineering efficiency. Simple example is a chiller. We define a chiller efficiency as kilowatt per ton. Now chillers are coming at even less than 0.5 kilowatt per ton. When I was leaving the university, chillers were operated at 0.8 kilowatt per ton. 0.8, 0.85 can be even worse than that. New chillers are operating at even 0.4, 0.45, very much efficient. So these called engineering efficiency. And here we consider only one input, one single input. In this case, single input is energy, electricity, kilowatt. And we don't bother about the other inputs. And there's another efficiency called technical efficiency, where we consider all the inputs. But again, in both engineering efficiency and technical efficiency, we consider only the quantities. We look at how many kilowatts, how many labor hours, how many raw materials, kilograms or whatever it is. In both cases, we look at only the quantities. When it comes to the third one, for me, most important one, economic efficiency. The question it asks is, at what cost? So it gives a money value into system. One might say, go for the most efficient chiller. At what cost? Right? Is it required? Being engineers, we like to go for most efficient equipment, more sophisticated equipment. But you need to ask the question, do we need that? Do we need the most sophisticated equipment here? Do we need the most efficient equipment? Can you afford? Does my company has enough fund for this? So we need to focus more on economic efficiency. That's why I want to split and show. But our immediate attention will go to engineering efficiency. And sometimes we stop there. Don't stop there. Go into technical efficiency, end up with economic efficiency. Why are you always highlight this term economic, rupees and cents? We all, as engineers, we understand kilowatt, we understand BTU, amperes, volts, all kind of stuff. But your senior management, your shareholders, they understand only one language. They understand only one term actually, rupees and cents, or dollars, or sterling. So we should be able to communicate in a language which they can understand. You don't have much of a choice. For which you need to understand the economic background, economic status of all the affairs that your organization is going through. That is very important. That's why I thought of highlighting these three efficiencies. Right. Now, improving building performance. I have gathered few points, not really few points, there are about, I think, over 10 different points. This is not extracted from a particular document or book or anything. This is what I feel as important to demonstrate building performance. Other than one or two of these points I have highlighted here, most of them are related to effectiveness. One at the very top, energy performance is directly related to efficiency. Almost all the other points are related to effectiveness. So assume that there are about 15 points. Unfortunately, I have put bullets here. I have put numbers. Assume there are 15 bullets here or points here. Out of which, out of 15, 14 of them are created to satisfy your customer. But when I explain TQM, satisfying your customer all the time is important, paramount important, but there should be a term at what cost, at the minimum cost. That comes from your efficiency, which we cannot forget. So out of all these bullets, I will just talk about energy performance. Others I will just go through because each bullet will have its own presentation and it will take days, not only hours, to make a presentation. And I won't have expertise to cover all these bullets. But I will roughly cover, I will just mention what I meant by these performance criteria. Number one is energy performance that we will discuss a little later. And then facade. Facade performance, it's structural integrity and look and feel, appearance. That is important. So even though I say facade performance, structural integrity and appearances, this doesn't fall into, these do not fall into a particular engineering trade. Structural integrity may be part of civil engineering. Appearance may be some other discipline. And facade performance, I mentioned that facade has to act as your skin. It has to be airtight. It has to be strong enough to withstand winds. There shouldn't be water leaks. Air conditioner should not be leaking. There shouldn't be damp patches, right? Insulation should be sufficient. Glazing should be properly designed so that the heat gain will be minimized. So that is the functionality of the facade. Then a very important factor which will impact your occupants, indoor air quality and indoor environmental quality. Indoor air quality, you know that we are talking about the temperature, humidity, airflow, ventilation, all that, airspeed and ventilation. In addition to that, contaminants through various, I would say, through various sources and how to remove the contaminants. And then in addition to the IAQ, you have lighting and then visual comfort and acoustics. So this is also important. And to make things simple, at least maybe twice a year, you can get one of these local organizations to conduct a indoor air quality assessment within your facility. They will check the temperature, humidity, all that, and plus the contaminants like volatile organic compounds, particulate matter, formaldehyde, all kind of stuff, and see, and carbon monoxide, and see whether they have exceeded any of the limits. CO2, they will check all that and give you a report. And it's very important, modern day, your occupants are quite educated. They are no more in 20th century. We are in 21st century. So that they know exactly what you mean by indoor air quality. Especially people who have lived and worked overseas. They know what temperature you are supposed to maintain. What will happen if the indoor air is contaminated contaminated. So better to have these reports ready. Then this will become part of their compliance management as well. And then very important area, your system integration, that is BMS. And during the recommissioning process, which we do regularly, you have to ensure that all your instrumentation is in place and integration issues have been sorted out and the building is performing as intended. That is another way of improving your performance. And testing of and ensuring the quality of drinking water and the processed water. We all know about the Legionella disease, which can be spread in your condensed water system or the fountain. Preventive maintenance and predictive maintenance. Why we do maintenance of a particular piece of equipment? For me, there are 4 aspects. One is to improve the reliability. Number 2 is to improve the efficiency. Number 3 is to make sure the speed or the rate of operation or the production rate or something like that. And finally, reduce the rejection rate. So you can apply these things to building services as well, not only for manufacturing. Those are the objectives of maintenance. Then with the preventive maintenance, that's a good starting point. But now we are into Industry 4.0, where predictive maintenance and IIoT are working very close. Predictive maintenance, simple examples for electrical system, you can go for thermography. It's available in Sri Lanka. There are few companies, they can offer services. For motors, you can go for vibration analysis and signature analysis. And for generators, you can go for oil sampling, which gives you enough and more information about the condition of the generator, its parts, oil, and any contamination. These are important things. So when I just mentioned this, you might say that he has not gone into details. I'm giving you only the leads. You can do the study by yourself. Where most of the developed countries, they believe in self-study, not teaching everything by the lecturer or the teacher, or whoever it is. And for me to teach you everything, I don't know everything. I know only a little bit. But if you want to, if anybody want any clarification, you can call me directly. I'll give you any specific area, let's say generator oil sampling. Why we should do it? Right? When we first started to check oils and oil sampling of the generators, the generator service providers objected. Because we said, we don't want to service them every 6 months. For what reason? And we are wasting oil. So better do the oil sampling and prove us that the oil has lost its capabilities. It's lost its quality. The parameters have gone beyond the range. And we found all the parameters were well within the range. So we delayed the servicing by another 6 months. And with the oil sampling, that we delayed unnecessary services or reduced the unnecessary service. At the same time, we got additional information about the oil and the engine. That is very important. That is knowledge. So if you need any additional information, I can share whatever I know. Then the waste management is more important for hotel sector and the hospital sector. And there are many environmental standards and factory ordinance standards. And they are linked with many international organizations. Let's say hospitals are linked with certain international organizations to get their credibility up. So they need to do compliance, as I mentioned at the bottom, compliance management. Hotels are same, they are into various hotel chains. So to get the various guests, you need to have your compliance going, and waste management will be part of that. Fire and life safety is very important. I can remember a long time ago, we had a fire in the building I used to manage. And actually that was created by a cigarette. There was a fit out going on at night. The guy who represented the particular tenant, he was smoking inside the floor, which is also not allowed. You're not supposed to do that. But this was at night, so he was undetected. And after smoking, he has put the butt into a waste pipe bin. And fire erupted from there. And the sprinklers worked. It dammed the whole area. And I think water came down to about 6 or 10 floors. And some fires and some computers got wet. And next day, we had a chat with some of the tenants. And with all the damages, one fellow said, the damages are okay, we can live with it. But today we realize one thing, that your fire system is working. That is a good thing. Right? So then that is an indication how important fire safety, because you might need it only once in your lifetime, only once in your lifetime. But at that time, it should work. For you to make it work, that one time in the whole life, you have to test it regularly, you have to inspect it regularly, you have to rectify it regularly. That effort has to be there to save that one day. That's very important, because that will ruin the entire building, end of the building. Right? And without coordination, whatever the modification, improvements, alteration that you do building, make sure that you are not going to add any fire burden. And today, there are many different types of materials. Some of them are highly combustible. And we load them into your floors. Your fire loading will go up. And piling of combustible material like paper and all that, all the way up to your sprinklers. So this alteration, modification has to be controlled. And you have to have a document for that. And few things that we do, I have experience having a rainwater harvesting system. I think that is in the regulation. And designers, ask yourself whether we are just trying to do a workaround of the regulation, or are we really focusing on rainwater harvesting? And in addition to that, wherever you have AHU systems, you can harness condensate drain. That is very important, because that water is coming at very low temperature, maybe like 24 degrees. That is a good feed water system for your cooling towers. And space planning is important, because space is money. Sometimes back, when people occupy spaces like renting spaces and all that, they look for square area for their offices. Now, most of the modern business people, they don't look for area. They look for heads, number of people. How many people we can put in? That is an indication how well you have designed your space. How many people that you can put in? What will be my cost per person? That is their yardstick, not the floor area. So if the business community is changing their parameters, we have to abide by that. Otherwise, we'll become outdated. Right? And as the building services engineers, I always recommend you to expand your capabilities to soft facilities management services. Hard facilities management services is building services. Soft part is security, landscaping, what else? Cleaning, pest control, and integrating those. I had experience where these services were integrated. In case of a water leak in one of the floors, first people to run will be your cleaning staff. I have seen it. They run first with their wet and dry vacuum cleaners and all that. They do what? Then security run. They secure the area, switch off power and all that, and divert traffic and take photographs to see whether there are any damage and all that's required for next day insurance claims. Then only the engineering people will go. They will go and shut off valve or something like that. But at that time, most of the work has been done. Over a period of time, security people have found where to close the valves, where to switch off the power. They have realized all that. So this integration of these different services is important to improve performance. Last one is staff development and empowerment. Usually we call it staff training. But I changed the terminology. I said staff development and empowerment. So development is not just training, it's enhancement of knowledge. And once you enhance somebody's knowledge, or if you want to enhance somebody's knowledge, first thing you need to do is to enhance your own knowledge. If you have if you have a senior officer who enhances his knowledge all the time, is creating a passion for the entire organizations to enhance their knowledge. It has to be top down, never bottom up. So first enhance your knowledge and support your team, supervisors, technicians to enhance their knowledge. Once they enhance their knowledge, empower them to make decisions and you take the responsibility. And we'll be discussing about starting and stopping of chillers. Who should make that call? Your supervisor should make that call. And we stop the chillers. When to stop? He should make that call. So no point of empowering somebody without knowledge. So get yourself the knowledge and then make sure that your staff also get the benefit of it and empower them to make decisions. It makes your life easier. So these are the few things that I can highlight to improve the building performance. Unfortunately, we won't be able to go into all the sections, and there may be participants who are already operating buildings. They may have some other elements which can go into this list, or they might take off some of them out of this list as well. But this is what I can think of. This is practically what comes out from me. And then we'll look at more specifically about energy as is the topic for today. Now, this is the building sector, both in Sri Lanka, and I got some information from US that in Sri Lanka it's almost like 36% in 2019, and US it's more or less 40%. So we can say overall 20% of the energy is consumed by buildings, whether they are residential or commercial. Buildings consume about 40% of the energy that is produced in the country, and balance is gone for industries and transport. Then, being the building services engineers, we are responsible for 40% of the energy that has been generated in the country. Knowing that the cost of electricity generation is 40% is going to be very expensive for a country like this. And out of this 40% building, if you look at the total life cycle, assume that it is over a period of 30 years, 25% is for your development, rest is for your operation. If you are going for cheap first cost stuff, then your development cost can be even less than that, 20%, and operational cost can be even 80%. I have a experience when we were replacing a chiller. Basically we replaced 2 chillers, and the chillers were in brand new condition, operating at the original design efficiency. And when we were replacing the chillers, mainly as a result based on energy performance, there was a request whether we can give this chiller to a new large development. The large development, can we give them? I said, okay, I can give them free of charge. I don't want to charge anything. I'll give them free of charge. But within 3 years, you will be exceeding the value of a new chiller through the additional energy that this old chiller is consuming. Chillers were in brand new condition, no failures, and operating at original design efficiency. Nothing has gone wrong. But today, the efficiencies are so high, even if I give that chiller free of charge to somebody else, if you use it for 3 years, he'll be consuming more energy or spending more energy. With the increased tariff, I think the period will be even much shorter, spending more money, which he could have used to buy a new efficient chiller. Situation is that bad. Right? Buildings are so aggressive in terms of consuming energy. So within this operational cost, single large component is energy. Don't worry about these numbers. I have mentioned 70% here. This is the information I found. And in addition to that, I have spoken to many different industries like hospitals, hotels, and commercial buildings, I found that at least like the 50% of the operating expenditure is for energy. But unfortunately, the energy cost has not given that sort of attention, especially in hospitals and hotels. The simple reason is that their main business or the main activity is hospitality industry and healthcare industry. So they have a cost of sales, or the sales, that is their revenue, and they call it cost of sales. So energy doesn't fall into that, because energy has nothing to do with the sales for both hotels and hospitals. So sometimes this energy or the electricity cost or the utility cost might get hidden somewhere in administration cost or somewhere. I went through few P&Ls and I found that there are funny elements in that. And some of them are very close, or some of them even more than the energy cost. I found that the way they have arranged the P&L doesn't give that prominence to energy. So being the building services engineer, we need to go through the P&L. P&L stands for profit and loss account, and see where our energy is hidden. For a commercial building, which is very straightforward, like office building is very straightforward. Their sales come from the rent, and then all the expenditures are building services expenditure plus soft facilities management. So in that case, it's very straightforward. And I think the 70% here is mainly for office buildings. So then the point I want to highlight is that in operational expenditure, single largest cost is energy. That is something as a building service engineer we need to highlight. And first, we should get highlighted to ourselves, and then we make decisions to reduce it. And once you reduce it, it should be visible in the P&L as well, not anywhere else, or at least in the energy bill. It should be visible. Otherwise, no point. So out of energy, again, aircon is the biggest culprit. I have seen this number going up to about 55%, even 60%, or coming down to even about 33, 34%. This all depends on whether your energy system is efficient or whether your other energy using components are efficient, or whether your MVAC system is efficient. So depend on that, this number percentage will change. But the point to highlight is that it is against the single largest component in your energy bill, your MVAC system, aircon system. So if that is the case, I'm just highlighting your way forward as a facilities or building service engineer. So if this is the case, you should be focusing more on air conditioning. That should be your number one priority. It doesn't mean that you need to ignore the office equipment, lighting, and all that. No, you have to. But your number one priority, your biggest chunk is aircon. If you look at these percentages, if you multiply them together, your HVAC system becomes like 25% of the total operational cost for 30 years, total. Right? Of the first circle here, 25% of this will be your aircon. Just multiply these three numbers and see. Right? So that means our focus should be start or prioritize for air conditioning. This is how I started. And now it's worse because of the energy increase. And the last it was increased in 2013 or 2014. I think it's September, November. After about almost 10 years, there's another increase. Certain, if you are not familiar with energy tariff, here I'm not going to explain that in detail. This again giving you some information so that you can go to either Public Utility Commission, CEB, or LECO, Water Board websites and find this. Water tariff has been increased now. But here I have just give a summary, but this information has not been extracted from any particular document. Here I have done something very simple. I have plugged in some information data into the old tariff and to the new tariff and worked out what will be the impact. So this lag depends on numbers I have plugged into the tariff. Hotel sector, you get about, I think, 60% overall hit, and I think it comes in 2 stages because of the current situation. Industry, which in large industries will be hit badly because we have been subsidized earlier to a great extent, and general purpose people were paying for all the subsidies, and they were paying a much higher rate than the I think the generation cost or the sales cost. Right? As a result, the impact seems to be relatively less on commercial buildings, shopping malls, and other private sector buildings. It's about 30% overall. And the government sector is also badly hit because they have been severely subsidized. So now they have taken a stance that we don't want to subsidize. You pay as you consume. Even for domestic, I have not included it because that is not the topic for today. Domestic also, they have charged high because what they say is if you consume something, pay for it. Simple as that, right? So this is a more kind of a challenge for the building services engineers, as the prominence of the energy cost is going to be much higher with 30%, 60% increase. It will be a highlight in the next management meeting. So better think of reducing it. So when it comes to planning for energy, the next slide will give you a bit of a more description. Here, this is what I thought. This is actually what I did long time ago when I wanted to improve our energy. First thing, that you need people who can think. That's why I said you need to enhance your knowledge. Without knowledge, you cannot think because you don't have substance to think. So knowledge is a substance for you to think. So when you have people who can think, they will come up with burst of ideas. How can we manage? How can we reduce energy? What can we do? Right? So this thought process, this brainstorming will go into a plan. That's what you need to do. Get your champions to talk and get the ideas, and whatever feasible, prioritize them, go to energy management plan. With the management plan, it's not just a group of words. It should have what is the cost, what is the expected saving, and what is the payback. Because that is the only language people who are going to approve your document can understand. So once your energy management plan is approved, it will go into your budget. Without budget, you don't have money. It goes to your capex. So probably by September, your energy management plan should be ready to go into the budget. So after first cut or second cut, budget will be approved, and from early next year, you can spend. At the end of the year, you have to prove that you have spent and reduce the energy. And these are all additional work. Whether I save energy or not, I get my salary. Then why should I get additional burden? Replacing of chillers, chilled water pumps, condensed water pump, cooling towers. These are not simple things. Right? Most of the people don't want to take these responsibilities. Why should we? Right? We are managing somebody else's building. So then the organization should be fair enough to incorporate these energy conservation activities into the staff appraisal system. So that if you carry on these things, you will get your additional bonus, you get your additional increment, so that there's a benefit to the staff from top to bottom of the department, not only to the building service engineer. That goes into as the commitment when it is included in your objectives. So once you hit your objectives, you get your privileges. So then it's fair enough. Right? So as we go along, then you will learn about the energy pattern. You will do whatever within your knowledge to reduce it. After that, it's time for an expert to come and support you. Not at the very beginning. Then you will be clueless about what to do. So once this process is over, you need to sustain it. You might leave, your champions might leave, but the organization need to move forward. A certification like ISO 50001 will help you to sustain it. So this is the basic plan I can think, but it's more elaborated in the next slide. Okay. After this slide, I have only one slide. But this slide has so many links. So first, I will show you my thought process about saving energy. These are again not extracted from anywhere. This is what I think as more logical. But you can change the order based on your knowledge, based on your requirement. I just want to share what I think as appropriate. First, we need to convince ourselves how significant is our operating cost, which I have already discussed. Only thing what I want to highlight here is that be careful that you take only the non-core expenditure, because any organization has core activities and non-core activities. The prime activities of an organization and all the support services. Building services will come under support services. Soft facilities management will come under support services. Then you should be able to separate these cost elements. Whatever the sales or the revenue and the cost of sales and other relevant expenditure, let it be with the prime activity of the organization. Separate it from your expenditure. And then see what is the cost of support services. And then see how significant energy in that. I'm sure energy will be the single largest component in that. Then you are convinced that I need to do something on that. If I do something on that, I will get the necessary recognition for me as well as for my department. I will be a shining star because we have tackled the single largest cost component in your support service. That is very important for your organization, because most of the organization about 10-15 years ago, they focused mainly on their core activities, so primary activities. They were not very concerned about support services. Now they are very much concerned about the support service, the cost of providing support services and the quality of support service. This is the new trend. Then you have opportunity. Don't think that as a problem. It is an opportunity, right? So once you are convinced that your operating cost, the energy is a key factor of your operating cost, let's try to have a simple energy accounting system. You need to know where your energy is going. Many years back, we had only the utility companies meeting. Now the meters are quite economical. They can be networkable, and there are softwares where you can get whatever the information from the meters to a display that you can monitor. I will just show you a sample. This is from a medium voltage system, and you can see the transformers are here. There are seven transformers. On to your left side, there are many energy meters. All sub-circuits have energy meters. On to your right side is the low voltage system. There are only 3 meters here, in addition to their 10 meters. There are about 300 10 meters. That's not captured here. But for the main energy accounting system, they have picked the medium voltage side, that you have voltage transformers as well as current transformers. But after the transformers, you have only 3 meters here. This they have strategically selected. This is a large facility with so many circuits, but they managed to set up an energy accounting system using 7, 9, and 12 meters. Only there are 12 meters in the whole system to monitor to capture the energy in different segments. So this is very important. Somebody who doesn't look into it in a strategic way might go for 30, 40 meters. Useless. So this is the first thing. And then what can we monitor? This is the behavior of the energy consumption for, I think, 1 month period. From just looking at it, a person who knows about this facility will tell you whether this Monday, Tuesday, or Saturday or Sunday. Actually, this is Saturday, this Sunday, this Monday. So they have 2 feeders, the red one and the blue one. These are direct information coming from the meter. And the third one is green. This is not a direct information. This has been calculated through a formula and presented. All 3 can be presented like this. So there are similar presentations, like you can get power factor, and they don't have power factor in their medium voltage system. So power factors are all in the power factor banks are all in the low voltage system, but you can monitor the power factor. You can see in one feeder, power factor is quite stable. Other one is varying. This is about 0.98, other one is about 0.9. Because the second feeder is connected to many induction equipment like even elevators and all that. So the load is varying. So these all you can read. And this is the load pattern. And this is the time of use analysis. And here very important one about the energy consumption of yesterday compared to today. Yesterday's one in light blue, today's one in dark blue. So the supervisor in the plant room, he will see his colleague yesterday, how he has managed his, maybe the HVAC plant or AC plant. And he will try to beat his colleague who managed it yesterday by running the plant at a lower energy consumption. So this battle is there. This is a healthy competition. And they are not supposed to alter the indoor air quality. Nobody can touch that. You have to maintain the indoor air quality and find ways and means to reduce the energy consumption of your system. So by doing this, you can improve the performance. And there are few benefits. I will not go through all that of the energy accounting system. I have just given this slide. I think if you go into more like details, you can find what are the benefits like reconciling the energy utility bills, and then you can prove your energy conservation projects, right? You can trend information. Those are the benefits. So we'll go back to the main slide. And then once you set up your energy account, it doesn't need to be this sophisticated, it can be very basic system with some Excel sheets as well, right? And then you can prepare energy balance. This is where your energy is going. In this particular building, you can see the HV side, air conditioning. This is the water side, this is the air side. Total comes to about, I think about 33%. Very much low compared to the tenant and the common area consumption. But the same building about 15 years back had this somewhere around 55%. Right? Because the AC system was not so efficient. With this, you can decide what do I need to do? Where should my main focus? And it should be controllable. If your tenants are consuming, if they are paying for it, you don't have much of a control over it, even though it's high. Right? So this where you can control. This area also not much of a control, and this area you can control. Right. Once you get your focus, let's look at what are things we're going to achieve. That is benchmark. First, you need to see where you stand as a building in total. I've given you a small equation here, very simple calculation, right? Kilowatt hours per meter, per square meter per year. This I have extracted from Singapore Building Construction Authority and NUS, National University of Singapore. They have published this information long time ago, maybe in early 2000, right? And there are certain numbers here. I won't go through all the numbers. And when we started the building, the numbers were somewhere here, like 243. So that means the level 4, very poor, right? Poor stage. And over a period of time, we managed to bring this building to something like this level. Not here, not the excellent, but to like 155. I'll show you a chart here. In 2007, they were like 240. Somewhere here, 243 into fair. Not good at all. In 2014, within 7 years, it has been improved like 170. So one might say, okay, 240, 170. What's the big deal? So then you need to again convert it to rupees and cents. When you convert, I have given you a small formula. I don't think you need to read all that. The bottom line is, with this achievement, they have managed to save 140 million rupees a year. That is sizable, uploadable, and appreciable. The 70 kilowatt, 70, 100, 72 volt, nobody will understand. That only you will understand. And that has to be converted to rupees and cents and show this in the energy bill. By improving it, if you can bring it down by 140 million rupees a year, you are done. Right? You won't have problem of getting increment for yourself and your team. You won't have problem of getting bonus for yourself and your team. Won't be a problem. By doing this for 10 years, we managed to give increments, bonus without any problem. Right? That's why I said I would like to share my own experience. Next benchmark I have extracted from Singapore Green Mark. Here's what they prefer. This is like the baseline, not the best. Minimum required for cooling towers, chill water pumps, condenser water pumps, chillers, and overall plant efficiency. They think we should have at least 0.65. And these numbers you can find from Singapore Green Mark energy efficient, that is green rating system. This I have extracted from same place. Right? This is the baseline. This way as water side. And air side, it's a less than 0.3 kilowatt per ton. And overall baseline is 0.95 kilowatt per ton. This is the baseline, Singapore Green Mark. So this is a benchmark for you to consider. And if you are more concerned about ASHRAE, this is what ASHRAE says. Overall plant efficiency, this is the water side of your system. If you want to become excellent, it has to be less than 0.7 kilowatt per ton, overall plant efficiency. In one of the slides, I will show you a plant which was way above here, somewhere here, has been brought to somewhere around here with minimum effort. And this is an example of illustration of how somebody has achieved. This is online monitoring of plant room. So don't worry about this jargon too much, right? Because it's a graphic created by their own people. So it may not be very clear because they have put so much of information. So a normal person won't be able to understand. But I will just read out some of the important stuff. Cooling towers, they operate at 0.03. Condenser water 0.04. Chill water 0.05. Chillers, there are 2 chillers operating at that time, 0.43. And overall plant efficiency is 0.55. Hope you can remember. Here, 0.65. And ASHRAE, anything below 0.7 is excellent. So they are operating somewhere here. So somewhere here, 0.55. But unfortunately, the air system, air side is not very efficient. So it's not operating at 0.3, it's operating at 0.43. The reason is the VAV system is a bit defective. And one point I would like to highlight here. There are 2 chillers on this particular day. This was taken about 2 days ago. 2 chillers. See how many cooling towers are running. All 5 cooling towers are running at low speed. So this is not our normal practice. Which is normal 2 chillers, we run 2 cooling towers, 2 condenser water pumps, 2 chilled water pumps. And they're running 2 chillers with 5 cooling towers and 3 condenser water pumps at very much lower speed. You know that with the VFD, speed is proportional to the cube of energy. So when you run them at lower speeds, right, you save more energy. So even after running all 5 cooling towers and 3 condenser water pumps, they have still achieved the required benchmarks. Right? This is something for you to think, because we cannot discuss all the details because it's building specific. But the reason why I highlighted this, for you to rethink, if we run 2 chillers, should we run only 2 cooling towers? Can we run more? Only 2 condenser water pumps, or can we run more? That you need to study. The last one about the benchmarking is about the building maintenance cost. I will just quickly go through. In the budget, building services budget or facilities management budget, there is always a question, are you spending too much for your maintenance or too less? So I have given you a way to calculate it. If you know how much you need to replace your asset, we call it replacement asset value. And if you know your annual maintenance cost, just divide it by it. annual maintenance cost divided by replacement asset value. If you are getting a value between 1.75 and 2.5, your spending is sufficient. If you are spending too much, you are wasting. If you are spending too less, again you are wasting. So this is a good benchmark to prove your organization that you are spending only the right amount. Right. Then I'll show you a nice story. Okay. Look at this number here. This was the plant efficiency, overall plant efficiency for a building, 1.63. I think some of you probably have seen this before. I have shown this, right? And if you look at the ASHRAE standard, you are not even in the frame. But within very few months, they managed to bring this down to 1. What have they done? They have just replaced some of their instrumentation. Their flow meter, the condenser water and chilled water flow meters were not working, and they didn't have power analyzers. At the time of construction of this building, power analyzers were a bit of a luxury. But now power analyzers are quite cheap. 10,000-15,000 rupees, you can buy a power analyzer. They have just introduced ultrasonic flow meters because they didn't want to disturb the setup, and installed power analyzers, started monitoring or calculating the chiller performance online without a sophisticated energy accounting system. Just manual information extracted and calculated from time to time. And they have adjusted the chill water and condenser flow rate as per the design requirements. With such a simple arrangement, they managed to bring 1.63 all the way down to 1. Again, convert it to rupees and cents. I have done that. If you want to, can go through the formula. And at that time, energy was much expensive. It was 24 rupees per kilowatt hour because there was a fuel surcharge and all that. And with this minor improvement, we call it recommissioning, they managed to save about 60 million rupees in a year. 60 million rupees. And the cost of doing all these modifications was only 5 million. And they have installed 2 VFDs as well for condenser water and chilled water, only 2 units. And the total cost was only 5 million. And they have saved 60 million per year. And another point for operational improvements is that when to start your main plant. Right? Okay, now time is 7:30. I will try to finish few more slides, and by 7:45 I will stop the discussion so that any questions you can ask. I may not be able to complete everything, but let me just finish off these few slides. So number 1, after the previous slide, this one, when to start your chillers, how to work out the right timing. Can we start at 5 o'clock in the morning, 6 o'clock in the morning, 7 o'clock in the morning? Right? So they have illustrated, in this particular slide, we have illustrated several ways. The easy way is, there are 2 ways. One is that you can look at the chill water return temperature and then decide when to start the second chiller. But the more professional way is look at the outdoor temperature and prepare a chart. Assume that outdoor temperature is 32 degrees. How long it will take for your chiller system to bring down the temperature to acceptable level by the time you have agreed to give air conditioning. Assume that you have agreed to provide air conditioning at 8 o'clock in the morning. By 8 o'clock, you are supposed to provide air conditioning at 24 degrees. By 8 o'clock, space temperature should be 24 degrees. Not before 8 o'clock. 7:30 doesn't need to be 24 degrees. So then, if you start your chillers at 7:30, can I bring down the temperature to 24 degrees by 8 o'clock? Right? That is the question. So you can do a little bit of trial and error and decide whether you want to run 1 chiller or 2 chillers. Right? That's trial and error. You can do it. In one facility, I had a chat a few days ago. They just start 1 chiller at 7:30. And then they choose will also start. By 8 o'clock, they provide 24 degrees. And they wait to see whether this return air temperature is running or going up for them to start the second chiller. Sometimes they charge the second chiller only at about 9:30, sometimes even 10 o'clock. So this is the empowerment of your staff and educating your staff. So this is important while you are starting your chillers on time or just before they're supposed to start. You need to stop them early as well. Let's say you're supposed to provide air conditioning till about 6 o'clock in the evening. It doesn't mean that you have to run chillers till 6 o'clock. Right? You can stop them at 5 o'clock. How do you know? Very simple. You stop your chillers, chill water pumps, condenser water pumps, cooling towers. If you are not providing supplying any package units or anything, to make things simple, assume that they don't have package units, only central plant. You knock off your chillers, condenser water pumps and cooling towers and circulate chill water. So your chill water pumps are running and the air handling units are running. See how long it will take for the space temperature to go beyond your threshold. If you are supposed to give maximum 25 degrees, see how long it will take to go beyond 25 degrees. Let's say it's half an hour. So then, if you're supposed to give air conditioning till 6 o'clock, you can stop your chillers at 5:30. Without spending anything, you can save millions. Right? That is one aspect. Yes. Number one is, next one is chill water preset. So running chill water at a higher temperature is a good option. I learned this way back in 1998 when I was reading an ASHTRAE journal. And from there, that day onwards, we were running our chillers at an elevated temperature. When you increase your chill water temperature, it will increase the evaporating pressure. When the evaporating pressure is higher, your compressor doesn't have to work much harder. It has to work less. That's why I have illustrated in this particular diagram. But you have to be careful on that. When you elevate your chill water, it goes to your air handling unit at a higher temperature as well. If your air handling unit doesn't have excess capacity, it will have a difficulty of maintaining the temperature inside the space. And your AHU may have to work harder, so that AHU energy cost will go up. When AHU works harder, your chill water pump has to work harder. So then chill water pump division energy cost will go up. Right? Then you have to see overall benefit, whether it's positive or negative. Don't just increase the temperature without any control. And at the same time, one more thing you need to be worried. One objective of the air handling unit is to remove moisture. When you are giving chill water at a higher temperature, there will be a problem of removing moisture. So inside your premises or the space, moisture content for the RH may be higher. So then I'll show you an actual setup where there were two chillers operating on a particular day. This is how they maintain their chill water temperature. Chill water is leaving at 10.6. Most of the chiller manufacturers say run at 7 degrees. That is how it has been designed. But they are running at 10.6 and return at 16.8. Right? And at the same time, they maintain overall efficiency at 0.55. So that means your air handling unit, chill water pumps, and the condenser and the chiller, they all manage well. And we look at the inside on office. They maintain temperature at 23.7 because in this particular building is designed to operate at 24 degrees. And RH is maintained at 58. I think it's okay. Right? 55% plus or minus 55 plus or minus 5%. So they are operating within the limits. Similarly, you can do for condenser reset, condenser water reset, condenser tip by reducing the condenser water leaving the cooling tower. When you reduce the temperature, it will reduce the pressure. So when you reduce the pressure, that will make things easier for the compressor. Again, just like the chill water, when you try to reduce the condenser entering the temperature, your cooling towers may have to work harder your condenser water pump had to work harder. So then we have to see the energy consumption of the chiller or the savings from the chiller and additional consumption of the condenser water pump and the cooling tower and put together and see whether we are getting a net positive benefit. Right? In this particular facility, they have fixed the condenser water, leaving the cooling tower at a particular temperature. But modern day, we don't need to fix it like that. We can have the wet bulb temperature sensor, and then at the approach temperature, maybe 3 degrees on top of that, and make that as the condenser water leaving temperature. That will make things more dynamic. Okay. One more item about the air handling units. I think in certain facilities, air handling units, the VAVs can be monitored from the BMS. Certain facilities, you can't monitor VAVs from the BMS. If that is the case where you cannot monitor, make use of the duct pressure sensor and then control your VFT. When the duct pressure sensor builds up, that means VAV doesn't need that much of air. So you can reduce the speed of your VFT. If you can monitor the VAVs directly, monitor the VAV which is mostly open and try to maintain that. Whenever VAV opens 100%, your system will give more air. Whenever the VAV start to close down, the system will reduce the speed of the HU fan. This is called the static pressure controlling. This one I will skip because not very relevant to Sri Lanka. And now it is very relevant, this one, the demand control ventilation. And older buildings, you may not have CO2 sensors everywhere, but modern buildings, new buildings, I think we should have CO2 sensors here. So rather than just fixing our air supply on particular ambient conditions and the occupant conditions, number of occupants, we can fix the ventilation based on the actual CO2 level. So Sri Lanka current standard is 1250. That is 550 at the intake and 700 addition within the premises. So 550 plus 700 goes to 1250. That is the limit. When you hit 1250, you can start opening the ventilation. When it is less than that, you can close it. So for which you need to have a VAV system for your ventilation. And the last one for today, though I have some more slides, cooling towers. This is just a photograph. It will give the total picture. You can see some patches here. This is the growth of mold because of high humidity, high wet bulb temperature. And then this is the first cooling tower. This is the second cooling tower, which is placed against the wall on this side, as well as the other side on both sides. And the suction and discharge both are blocked, so that this particular cooling tower may not work properly. And then in addition to that, there's a funnel going up. So that means the air here may be a bit hot, so that your wet bulb temperature may be higher temperature at a higher value, so that you will not be able to cool down condenser water as you wish. And in addition to that, I think you are already aware that we need to maintain the concentration or TDS with number of cycles, avoid overflow, and avoid dry air disease by reducing the volume of water. I think, yeah, it's about 7:40. So I'll conclude the lecture at this point rather than going to rest of the information to save time. Then if there are any, okay, moderator is online. If there are anything that you need my clarification on what we have discussed already, I can make the necessary can give the necessary feedback.
Thank you, sir. Good evening. Can you hear me properly?
I can hear you. No problem.
Okay, I think others also can hear me. I'm Maheshudhyanga from Building Service Engineering Sectional Committee, and today I am working as a moderator in this lecture. So now we are going to start the Q&A session. So I will direct all the questions which you have posted in the chat box one by one. Actually, we have 3 questions, but I believe you have more than 3 questions. So after these 3 questions, we will give chance you to direct the question directly to the Engineer Indradeva. So Engineer Indradeva, let me present the questions. So our first one is, as there are many high-rise apartments, for each such apartment is a building services engineer necessary. What is the going monthly rate for such a BS engineer?
Okay,
Can you
it's
got,
like this.
can you got it?
Yeah, I got it. Thank you.
Okay.
Well, if you consider apartment complex, the most complicated system and most energy consuming system, that is your aircon system, is not there. So then compared to like a shopping mall or office building or a hotel or hospital or any industrial facility, apartment complexes are not that complicated. So that having a building services engineer for apartment complex may not be viable. I don't think any of the building services engineers should focus on apartment complexes. Individual, one apartment complex. There should be like a assistant engineer who can manage apartment complex, because you won't have central aircon. You'll be having a fire system and other ELV systems, then the electrical system, so that the whole system is not that complicated. And in apartment complexes, the number 1 priority is to reduce the service charge. That means they want low cost operation. So they won't be able to afford a qualified building services engineer for apartment complex unless they really want. But the option is to appoint a qualified building services engineer to look after many apartment complexes. The managing agent may be running, let's say, 5 apartment complexes, sizable apartment complexes. Then he can afford to have 1 building services engineer to manage all 5, all the engineering aspects. That is viable. But having an individual building services engineer for each apartment complex, for me, it's not viable.
Okay, so thank you.
Like in most advanced or matured industry in countries like Singapore, 1 building services engineer manage about 10 apartment complexes. Sometimes they manage estates. We call them estates, apartment estates, large number of complexes. Because Singapore is slightly different, because everything is outsourced, all the services are outsourced, there's nothing in-house. So it's a matter of coordinating. But in Sri Lankan context, I think a single building service engineer can coordinate and manage about at least 5 to 6 apartment complexes.
Okay, sir. Thank you very much. Next question is, it is evident that FM person is not involved in the design process in the traditional practice, but now it seems very much important for large projects this is to be happen. In what aspects FM can give considerable input to the design process?
Okay, the role of the facilities manager is more like a integrated process, where he should be able to integrate different aspects like soft FM and hard FM and give one solution. So an experienced facilities manager with some building services knowledge will be a good resource for the design team, because the facilities manager, or even you can give any designation, but for me, a person with certain qualification and experience in sizable building, for me, that is the facilities manager. Right? You should have sufficient qualification and experience in a sizable facility. He knows exactly how things work in practice. The designers and contractors, let's say designers, they don't have much experience in terms of the music that the building operators are facing. A facilities manager will know exactly what problems that they will have in the future, so that he can educate and highlight things that might go wrong if you don't take any action or incorporate anything into the design. So that their input is to fine tune the design so that your design will be a workable thing and will not have any negative impact when the building comes to operation. That will be the role of the facilities manager. If you want, I can give you a simple example as well. Recently, I visited the apartment complex, and then I found they don't have a water supply for the common area in typical floors. There was, I think, 20 odd floors. So the cleaning people, they had to clean the floor. There are large common area. They had to clean it every day. And for one janitor to clean one floor, she has to go down all the way to the car park level 2 or somewhere to bring a bucket of water and throw away the wastewater, maybe about 5 times just to clean one floor. Right? So this would have been avoided if there was a facilities manager's input has been taken, because he has seen this as a facilities manager. I have seen it. So I definitely highlight it. So that is like a valuable input that you can expect from a facilities manager during the design stage.
Okay, sir. Thank you. Next question is, we use inverter type AC as an energy efficient system, but we experience high insulation and maintenance costs. Requesting to express resource person concern on this regards.
Okay, I think there may be many people representing the building services sectional committee who has experience in that. I'm not an expert in air conditioning, but for me, inverter type air conditioners are good if you use them for a longer period. So they will settle down, the temperature will settle down. After that, the energy consumption will be minimal. In our normal air conditioners, when the temperature reaches the set point, it knocks off the compressor. Right? Then the temperature rise, again compressor has to start. So the compressor will be running at full power. But if you are using this aircon for a short period, in most of the apartment complex, this is what I have experienced. In many apartments, so-called luxury apartment, going at about 50 million, 60 million apartments, they don't use air conditioning. That is very funny. Right? Design capacity is about 2000 kVA. Running at about 200 kV. That is the maximum demand. So most of these people are not using air conditioning to that extent. Other than the embassy people and expats, they run them on 24-hour basis. For them, the inverter type AC is more viable. But for people who don't use air conditioning, or they use sparingly, maybe for 1 hour, maybe half an hour, something like that, then I don't think you need to invest on an inverter. That is my understanding.
Okay, sir. Next question. Is it advisable to switch off some of equipment fitted at the beginning, such as escalators, elevators, and extra lights in means of saving electricity?
I didn't get your question.
Okay, I will direct again. Is it advisable to switch off some of equipment fitted at the beginning, such as escalators, elevators, and extra lights in means of saving electricity?
You can, but if you have gone through what I have explained, first knock off the big chunk. Your Lukucal will be your air conditioning. That will be your focus. When you switch off escalators, when you switch off lights and all that, that gives a negative impact, negative impression about your building. They feel that you are going bankrupt. That's why you are switching off lights. But if you do it logically, instead of switching off escalators, you can make them sense operated. When the escalator is not used, escalator will stop. As soon as somebody comes near the escalator, the escalator will operate. That will be a better solution. But if you stop escalators when people are moving up and down, they have to use escalators as steps. So that is an indication that you are not really looking after the end user's requirement. Right? So switch off lights is okay, but do it more strategically. Switch off lights wherever you don't need them. But if you knock off the lights in your building, maybe like office building, that looks very dull. And people, especially ladies who are working at night, in Sri Lanka now, there are people working round the clock. There are shifts. So people who are going after about maybe 2 o'clock in the morning, going off from office, they feel very insecure. The entire building is dark. So that gives the wrong impression. So you have to be careful. Saving energy is okay, but don't bring a negative impression about your building, because that will be more harmful than using energy. So then when you save energy, save the big chunk first. That itself will be sufficient for you to sustain. The lights will be the last to touch, I suppose.
Okay, thank you, sir. That's all about the question available in the chat box. So based on the time available, we can go for raise hand question option 2. And if you have any further question, please use raise hand function. Then we will allow you to direct the question to Engineer Indradeva. If you have any question, please raise hand. It seems no more any questions. So
yeah.
Now time's up. So therefore now we came into latter part of the program, and I will invite to Engineer Ishan to conduct the session, concluding session. Thank you. Engineer Ishan, over to you.
Yeah, thank you, Mahesh. I hope you can hear me. And
yeah, we can hear you.
please bear with me turning on my video, because if I turn on my video, you won't hear me. That's how the internet connection these days. So everything don't last forever, and so as this seminar. But I am quite sure that Mr. Indradeva can speak about this subject on and on for days. But it is astonishing how well he explained the key operational performance aspects of buildings within this short period of time. At the outset, on behalf of Building Services Engineering Sectional Committee and audience, I thank our resource person, Mr. Indradeva Mendis. We are really enlightened with delivered knowledge and your presence, of course. Truly, you are such an asset to our industry, of course. Again, I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this webinar. That's ISL and his staff for making arrangements to host this online session. And again, at last but not least, I thank our audience for being with us as always, and we expect your participation for the future events organized by the Building Services Engineering Sectional Committee. So, to conclude the session with all these warm words and messages, we move to end of today's webinar. Thank you very much and have a good night.